Now let's get into trig functions. The first two functions that we will focus on are sine and cosine curves. To sketch the graphs of these basic sine and cosine functions by hand, it helps to note 5 key points in one period: the x-intercepts, maximum points, and minimum points. So if I have the function f of x equals sine x connecting to the unit circle, I know that one full period is a length of 2 pi. So at 0 and at 2 pi, we know that sine is 0 from the unit circle. We also know the halfway mark at pi, sine is also 0. Now in between those zeros, sine has some maximum and minimum values. It curves upward to a maximum of 1. At pi over 2, it curves back down into 0 at pi. It goes down to a minimum of -1 at x equals 3 pi over 2, and then it comes back up to 2 pi with a value of 0. The sine curve will always look this way. This is the parent function of the sine curve. So the same goes with cosine. If I have f of x equals cosine x as my parent function, I use the unit circle to determine some points of interest. Now, using the unit circle, we know that at 0, cosine is 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1. So cosine curves will always have this same shape in one period using its parent function. But I want you to note that these graphs only show one full period of each trig function. Periods repeat indefinitely to the left and right because you can rotate around the unit circle forward and backwards as many times as you need to. So once we know our parent functions, sine x and cosine x, we can transform them. And this should look very similar to when we transformed algebraic functions. There's just a couple differences. So instead of calling this a vertical stretch or shrink, we call this the amplitude, right? And the amplitude is how high up your curve will stretch from this 0 line, from the x-axis. The period is something a little different, right? That is one full period of a sine curve. And note, it does not always have to be 2 pi. The way we calculate our period, how long one full curve will be, is we take our b value and we divide that into 2 pi. Now, the minus c and the plus d are exactly how it used to be with our previous transformations. We have a horizontal shift of c, but they call this a phase shift for trig functions. You know, it's just new vocabulary because it's trig. And we have vertical shifts up or down by d. So when we're given a trig function, we can use the parent graph and know the basic shape of these 5 key points and transform any shape for sine and cosine.